Hey, I'm Pat, and in this video I will be going over the task library in Roblox Studio. As well, in this video I will be going over kind of threads and how threads really work. This might be kind of a difficult video, I don't know, it shouldn't be too hard to figure out. I'm just going to be going over a few functions that the task library has. Not all of them. The task library doesn't have many functions, but I'm only going to be going over maybe like 4 or 5 of them. That's all I feel like I should really be putting into this series. There are ones I don't think are too necessary for this video or whatever, right? So, the first thing I want to go over is obviously Task.Wait. I've went over this in my other videos. God, this is so close. Alright, I've went over this in my other videos where Task.Wait just yields the current thread. I don't know if I've talked about threads before, but I will sooner in the video. But yeah, it tells you right here, it yields the current thread until the next heartbeat. And the heartbeat can pretty much just be thought of as a frame, even though the heartbeat's actually like a part of a frame, but you can think of a heartbeat as a frame in which the given duration in seconds has passed. So pretty much every frame, it will check to see if the amount of duration that you've given it has passed, and if it has, then it'll continue. If it hasn't, then it won't, right? So you can give it something like 2, and it will pause the current thread for 2 seconds. So we can do something like print 1, and then Task.Wait 5, and then print 2, right? And then obviously after 5 seconds, 2 will be printed after 1, right? Now something also to note is if we have a thread, so a thread can be, see, this script has 1 thread, right? So if we have multiple prints here, actually let me just undo everything. So if we start here, the script's going to do everything in order. It's going to start from here, run this line, and wait for this function to finish, and then once it does, it'll move on to the next line and run that line. And once this line's done, it'll move on to the next one, right? So that's a thread. And we can have multiple threads within a script, but the script itself only starts with 1 thread. And there's a few ways we can create different threads. One of them is actually with the connect method. So that's for things like events. So getting get service players, player added, and then we connect it to a function. And this is actually creating a thread. Every time that the event is triggered, it creates a new thread for this function. So that way this function, or the code inside this function, is not actually interrupted by other things going on inside the script. So you could have multiple event connections inside of one script without having to worry about them interrupting each other, pretty much, right? So another thing to, of course, take note is if we have a while true do loop here, the way that obviously the thread works is it'll go line by line. So enter this while true do loop, and since there's nothing stopping this loop from ending, it never gets past this. So it'll never actually make this event connection here. So that's actually kind of annoying if you're using a while loop like that. You can't have, you know, like things after the while true do loop, because it's not going to function. Nothing after that's going to be executed. And this can also be used for scripts and things like that. Sometimes you don't want to yield the script for a function call. Like if you're stunning a player, like if you have a custom function for handling stunning a player, obviously you're going to be using Task.Wait to unstun the player later on. And you're most likely not going to want that to pause your script, because it will pause your script because it will have to wait for the function to end. So a way to avoid something like that is with something called Task.Spawn. And what this does is it actually just creates a function or a thread, right? And it executes the function that it's given in that thread. So it's actually very similar to connect, where it takes a function as an argument and that function runs in a separate thread. Except for connect, the function is called every time the event is triggered. But in Task.Spawn, it just immediately runs when you call Task.Spawn. There's also coroutines, which is more like a more advanced way of using Task.Spawn, but a large majority of the time you're going to be using Task.Spawn because you don't really need coroutines most of the time. They're really kind of overcomplicated. I don't really use them. I can't think of a time I've ever actually used them. I tried using them once and I figured they were too complicated, so I just moved on and used Task.Spawn. So obviously we can do something like this, but we can also call a function. So if we have a function like this, since I already used the stun player, we'll go ahead and use that as an example. And we're going to need the character in order to stun the character, right? And the thing is, obviously we can put stun player as the function that we want to call with Task.Spawn, right? But we can't give it as argument, right? Well, we actually can pass arguments this way, but usually your initial thought would be to do this. But if you do this, you're actually just calling the function instead of making a reference to the function. You use the function's name to kind of reference it, right? So instead, what we would do is something like this, and I'm actually going to put it down in here because then we can actually get a valid player, and we can do player.character. And now what it'll do is it'll call this function and it'll pass the player character as the first argument. So you can give the function as the first argument, and then any extra arguments related to that function can be passed after that in the argument list of Task.Spawn. So hopefully that makes sense on how that works. I can give you a quick example real quick. So if we print 1 here, that will print 1, and then we print 2 here, right? But what I'm going to do is actually do Task.Wait inside this function 5 seconds, and we will print 3. Now, actually, I'll comment this out real quick just to make show you how it would work normally. So if we call the function normally, like this, obviously it's going to print 1, and then it's going to call the function. So it's going to go through the function, it's going to wait 5 seconds, and then print 3. And then once the function's done, it'll print 2, right? That's how the executor works. So we go ahead and test it, hit run. Hold up. Plugins. No, that's not what I wanted to do. Plugins, manage plugins folder. Alright. So we go ahead and run. Try this again. Get nothing? What just happened? Oh wait. I have to actually play the game because for a player to join to trigger it. So if I join, you can see we get 1, and then 5 seconds later we should get 3, and then immediately after we get 2, right? So that's how you would expect it to work. But if we comment this out and we use Task.Spawn instead, this will prevent our script from, or the current thread from yielding in that place, right? So now it prints 1, 2. And then 5 seconds later, it should print 3, right? So now it does it how we want it to, right? So that allows us to do other things in here without kind of yielding the current thread. Very useful. Hopefully that's a good explanation on how threads work. You don't have to think about them too much. They kind of make more sense as you go along, I think. But don't give them too much thought. If it doesn't make sense, it's whatever. Task.Spawn is still kind of useful to use. If you don't fully understand threads, you can still use it, I would say. And then the next one I want to go over would be Task.Delay. So the way that delay works is it'll take here, we'll do print 1, and then we'll do Task.Delay. And the way it does is it will pretty much call a function after the duration that you give it. So the first argument would be the duration, so how long you want to wait before calling the function. And actually I wish I didn't delete that function. Alright, print 1, and then we can do Task.Delay 3, and then we can do stun player, right? Now we don't actually need to pass to the character because we're not actually using that argument, so I'm not going to do that because it's not necessary, but I'm pretty sure you can, yeah, you can pass arguments afterwards if you need to. And I believe this returns thread. Yeah, it does. We're going to go over that in a second, but So pretty much after 3 seconds, it will call the stump player, and I believe it will call it in a separate thread. So I'll go ahead and do print 2 after this again. So it'll print 1, it'll print 2, and then 3 seconds later, it'll print 3. I will get rid of that task.wait. Or, actually no, we can get rid of it, yeah. So I'll go ahead and play it, show you how it works. So printed 1 and 2, and then 3 seconds later we got 3, right? So it's pretty simple how that works. It's pretty useful for something like, say you have a custom way of destroying a part, or like you're using a part for like a particle system or something, and you want to maybe tween it once you destroy it, right before you destroy it or something. You could have a function that pretty much handles you destroying the part, and you could use task.delay to kind of delay it. Now you can also just define a function inside of here. You can do the same thing with task.wait, just kind of like how you can with connect. This is called an anonymous function because it doesn't have a name. It's not a named function, so it's anonymous, right? So you can also do it that way. So that's pretty useful, right? Now say we call this, but we actually don't want this to complete. Like we have a condition that's met that means, hey, we don't want this to actually go through. We want to stop this from working. What we can do is actually store this thread. Something like this. We can store this in a variable. So pretty much we got the thread. This is a special data type. It's a thread. That's what the data type is, right? So we can store the thread. The same thing for task.spawn. If we want to stop the task.spawn, we can store it inside a variable, and we can use task.cancel to cancel the thread. So if we had something like a while true loop inside of a task.spawn, we could theoretically later on inside of our script cancel it if we need to for some reason, right? So that's a good thing to do. So what I can do is task.cancel, and I'll go ahead and pass it the thread. And what we'll do is we'll do this after 1 second. And we'll do print 2 right after we store the thread. So it'll print 1 and 2, and then it'll wait 1 second and cancel the thread. So it should not print 3, right? So we'll go ahead and test it and see if it prints 3 or not. See, it printed 1 and 2, and it's definitely been more than 3 seconds, and it hasn't printed 3, right? So we canceled a thread, we prevented it from working. And it's also very good for cleaning up garbage, kind of like connect, where when you connect an event, sometimes you might need to disconnect it later on in a script because you don't want to have multiple connections on the same event most of the time. It can be kind of the same way where if you need to, you can store the thread in a variable and cancel it at another time if needed. So it's a pretty useful function. Really, that's all I wanted to go over for the task library. I didn't really have much to go over here. As far as making something with this, there's not really anything special that you can do with this to make. I guess I could go over like using task.delay or something like that. So, if you want to make something, let me think. Why don't we do something like we make an explosion, or like we summon so we have a tool, right? I already did this in a previous video, but we could do it and like we can make the code a lot cleaner, right? So why don't you make a tool, and with this tool, once you activate it, it'll pretty much create like an explosion around you, or maybe summon like a little puddle under your feet or something. And instead of just destroying it later on or adding it to the debris service, what you could do is have it custom tween once it finishes. So pretty much like after the duration is up for the explosion, have it like tween back in, or tween its transparency to 1 or something like that to make it kind of like disappear a little bit more satisfying than just like poof, it's gone, right? So obviously you're going to be using task.delay, you're going to be using task.wait. Are you? No, I don't think you're gonna need task.wait. But yeah, you just make like a little bubble. You don't have to like give it damage or anything, go crazy. Just make a bubble, and after a few seconds, it'll kind of tween back and go away. Obviously, you can make it tween into like show as well, kind of thing, whatever. So I'm going to go ahead and show you how I would do it. If you want, you can try and make it on your own. I'd recommend you do. It's always a good thing to try and make stuff on your own. But I'm going to go ahead and try and make it. Well, I'm going to make it. I'm a pro scripter, guys. I can make anything, honestly. Alright, maybe not anything, but it's alright. So what I'm going to do is I'm already going to create our part, which saves up our code a little bit because we don't have to set custom properties for our part inside of our code. So it makes it a little bit easier. However, we're going to start its size maybe at 1. We're going to give its transparency a start at 1, and we'll make it red this time. I remember my editor got angry because I said it was red, but it was actually orange. And I looked back at the video and was like, oh yeah, it was orange. But this time it's actually red. You can see even Roblox Studio agrees with me, so no more arguing. And I'm just going to make it smooth plastic. Or we can make it neon. That looks cool. Yeah, there we go. So we got this little ball thing. And what we'll do is when we click the part, or when we activate the tool, we'll go ahead and summon a ball. So I don't know what I just did, but I want to make a tool. There we go. So we're going to put this in a starter pack, and we'll just call this boom tool. Boom tool. And I'll give it a server script because that's all we need for this script. And I'll take this part and I'll call this explosion. And what I'll do is I'll actually make a folder inside replicated stores called VFX, which will store all of our VFX, and we'll put explosion inside of it. Now what I'll do is call this boom handler. Give it a, oh, that is not boom. So we're gonna call this boom handler, and alright, we're gonna call it boom handler, and we're gonna get the tool, and we'll also get tween service. Actually, I like getting services first. And now what I'll do is I'll actually make a function for our part for destroying it. So I'll call this remove explosion, and what we'll do is we'll take a part and we will create a tween to pretty much make the part transparency 1. So what we'll do is we'll create a tween on the part, and I'm going to do it the messy way because, or I guess you could call it the short way. Tween info.new, and we can do 1 second. Now tween info, you can give it as many as you want, so obviously the minimum is a duration, so we'll give it 1 second as the minimum. That's all I really need to do. And then for the last thing, what we need to do is give it a dictionary. So we'll give it a dictionary, and we'll say that we want to change its transparency to 1. So that's a really short way of making a tween without like having a bunch of variables and things like that. But sometimes it's good to have the variables because you might need them later on or whatever, right? So then we'll go ahead and play it, and we will actually task.wait 1 second, and after the 1 second, what we can do is actually destroy the part. Alright. And now what we'll do is tool.activated, and we'll connect it to our function. And we're actually going to want a debounce for this as well, so we're going to go ahead and make a debounce real quick. And in this video, you guys are going to be learning how to use os.clock as a debounce, because I just made the choice that I want to go over that in this video, even though this video is getting kind of longer than I wanted it to, but it's alright. So what we're going to do is if debounce is greater than os.clock, then return end. So after that, what we'll do is debounce equals os.clock plus let's say 2. So the way this works is os.clock is a function that pretty much returns a big number, and you can think of this number as like a number that has been counting up every second since your CPU started, pretty much. It's a little bit more complicated than that. but the way you can think of it is based off of CPU time. If it's on the server, then it's going to be based off of the server's CPU. If it's on the client, then it's going to be based off of the client's CPU time, right? So pretty much every second, it will be counting up one number. And this will actually also count milliseconds, I believe. os.clock counts milliseconds, yeah. So it can actually be pretty accurate for measuring time. Now, usually what you would use for a debounce is Task.Wait. That's what people like to use, but that actually yields a thread, which can actually be kind of having a performance impact. And you don't really like doing that. You want to kind of keep the amount of threads that are currently active to a minimum, right? So the way we can do that is by pretty much returning instantly. And if we return in this function, that pretty much ends this current thread that we have running right now, right? From this activated event trigger. So what we can do is we can compare our debounce, which is storing pretty much 2 seconds into the future, and compare that to our current time. And if it's been over 2 seconds, then we can return. Or if it's been less than 2 seconds, then we can return, because if the debounce is greater than the current time. So this is pretty much the time that we want to get to for the debounce to be over. This is our goal time, right? So once it reaches this time, it will this is always so complicated to explain, but once it reaches this time, it will pretty much know that the time's up by comparing it to the current time. And the way that this works here is, I probably should have explained this first, right? But it takes the current time and it adds 2 seconds onto it, right? That's what the +2 is. If we want to do like 2.5 seconds, we could do 2.5. But you can't use that with os.time or tick, because they don't have decimal place, only os.clock does. And what that'll do is it'll take the number returned from os.clock, which is pretty much thought of as the current time, and it'll add 2 seconds onto it and store that in this debounce. So that way we can tell when 2 seconds has passed, then we can continue on. And if it hasn't passed, then we can return an end. So this is just a guard clause. It's kind of, I've gone over it in previous videos, right? So we could also reverse this and do if debounce is less than os.clock, and then we could have all of our code inside this if statement here instead of returning. But it's a little bit better to do it this way. I'd rather do it that way because it removes one of the indentations and it looks a little bit cleaner, right? So now that we have that, let me stop talking and actually make the script, because we're getting kind of long. So we'll make an explosion, and we'll do game get service replicated storage .vfx.explosion, and then we'll clone it, explosion.parent equals tool.parent humanoid root part. Oh god. Position. Position? Yeah. And I want to use position here, not parent. We're going to parent it to workspace after. Explosion .parent equals workspace. Alright, so we're getting the humanoid root part by the tool's parent, which is going to be the character, right? We know that the tool's parent is the character because we're inside the activated event, which means that the character has to have the tool equipped for it to be called. And then we get the humanoid root part, which is their main part pretty much. And we just set it to that position. I've done this before, right? And then we'll make a tween to make it kind of blow up like. And what we'll do is size equals vector3.new 555. Make a nice round, and we'll do explosion. And now what we'll do is we'll play our tween, and now we'll get to the moment we've all been waiting for, task.delay, and we'll wait 1 second before calling our remove explosion function, and we have to pass it our explosion by just adding an extra argument in there. And this will be the part that we want to destroy inside this function, right? So that will do that. And now we could actually put more things after this if we wanted to, like maybe after a second we want the part to like maybe like, I don't know, like bounce in its size or something like that, or like change its transparency or color or something. We could do that. Task.Wait 1 second. I'll just copy this again, and what we'll do is color 3.new, and we can tween it to yellow, and now pretty much tween it to yellow as like we're deleting it. Oh, I used .new instead of from RGB, but it's the same thing, whatever. So we'll go ahead and test it now to see if it works. I forgot to anchor it, didn't I? Hold on. Make sure it's anchored. It wasn't. See, I'm thinking ahead into the future. I'm kind of God. Alright, this is a 20-minute video. Goddamn. And it's not even working. What? Oh, I forgot to fix this. Alright. Alright. Still not working. What? What did I do wrong? Forgot to turn off requires handle on the tool because we don't have a handle, so I'm also going to turn off can be dropped because we don't need it being dropped really. Alright. Boom. Forgot to turn off can glide, but it looks kind of cool. You can see after a second it kind of tweens its transparency, and also turns the color yellow because we have that task.wait. The task.wait's kind of pointless here. We could do more like 0.5 maybe, and turn off the can collide here. I'm being kind of picky. This video should be over right now, but I'm gonna do it anyways. It's a 27-minute video, too long. That actually looks kind of cool. I'm satisfied with that. We can make it bigger, and it's a little slow, but you get it. You get the idea. Anyways, that's it for the video. Thanks for watching. I'll see you later.